welcome you all for lecture number 17 of chapter number 2, time domain representation of LTI system. The topics covered for today's lecture are systems viewed as interconnections of operations, interconnections of LTI systems, relation between LTI system properties and impulse response. Three topics under this heading. The very first being system viewed as interconnections of operations. So here we represent a system with an operator called H, and we represent the input as x of t, output as y of t, and mathematically we write it as y of t is equal to h of x of t. This is like I'm applying input x of t to the system H to receive y of t. This is for continuous time signal. For discrete time signal, we call it as y of n, h, x of n as an input. This is for discrete time signal. Okay. So for shift operator, we use sk. So if x of n is the input, your output will be x of n minus k. For example, if my input is x of n and the shift operator is given as 1, or if it is not written any 1 here, if it is just yes, the output is x of n minus 1. If it is x of n as an input and if it is s raised to minus 2, then output is x of n plus 2. So this is how it goes. So it is plus 1, so you should write it in this manner. If it is minus 2, it should be written in this manner. Okay, now I'll take one example of moving average system. Y of n is equal to 1 by 3 x of n plus x of n minus 1 plus x of n minus 2. Okay, so now what I'm supposed to do is h means it's y of n divided by x of n, not exactly but almost, not exactly but almost. So here actually this division can be done only in frequency domain. We are right now in time domain, but right now you assume that, so it can be taken in this manner. So if I want to take in this manner, so 1 by 3 will be left out. So x of n, if it is taken common, and I am taking it to the denominator on the other side. So y of n is here. I'm taking x of n on the other side, left hand side. So it will come to the denominator. What is left here? So in x of n place, you write it as 1. Here you have to write it in this manner. 1 is amplitude, yes, raised to 1. One time it is left shift. That's the meaning. So here how it is written? It is s raised to minus 2 means n plus 2. Here it is s raised to it is n minus 2. Hence it is written as s raised to 2. This is how it is written. Now to implement it, to write it in the graphical form, I have two methods, two forms. First form is cascade form. Second form is parallel form. So these two things, we will draw the diagram in the next slide. So cascade, I'll write the equation once again. H is nothing but 1 by 3 1 plus s raised to 2. So cascade form I'll implement first. Cascade form looks like this. Just listen. X of n is the input. Okay. So first x of n is there. Then I have to shift it 1 times. If I shift it 1 times, what do I get? I get x of n minus 1. And x of n minus 1, I treat it as an input. I'll shift 1 more time. What do I get? I get x of n minus 2. I have all these three things now. So look at the question. X of n is there, x of n minus 1 is there, x of n minus 2 is there. X of n is there, x of n minus 1, x of n minus 2. All three are there. Now I have to take all these three things. I have to sum it. So it is adding addition of x of n plus x of n minus 1 plus x of n minus 2. Now I have to multiply it with a constant 1 by 3, and that will result me y of n. This is a graphical representation of the system in the cascade form. Now the same thing if I want to implement in parallel form, this can be written as, first at the left side x of n is the input. So one time I shift, I get it as x of n minus 1. Two times I shift, I get it as x of n minus 2. I don't shift directly, I'll take, here I'm having x of n. All these three things together, I add it. So here you need to put a plus mark. Add it. So I get addition of x of n minus 1, x of n minus 2. So for this, I scale it with a 1 by 3. I'll get it as y of n. This is parallel form. Cascade form is, so delay is more here. For example, x of n to x of n minus 1, there is some delay. X of n minus 2 can be got only after two processes, two units, first unit, second unit. That time it will be available. So summation happens only after two time units. So here what is happening? X of n is readily available. X of n minus 1 and n minus 2 will be available only after one time units. This and this will be happening parallelly. Hence, summation happens at one time units itself. This is comparatively faster, but it needs more hardware for implementation, because here I need only one time shift two times. Here I need one time shift one time, two time shifter one time. So it needs more hardware. So this is the difference between the implementation of cascade form and parallel form. I have one more problem. Express the operator that describes the input output relation in this form. Y of n is equal to 1 by 3 x of n plus 1 plus x of n plus x of n minus 1. So in terms of h, if I ask you to write, you will get it as 1 by 3 here, s raised to minus 1 plus s, sorry, not s, it is not shifted version, it is just 1 plus s, that's it. So if I ask you to implement it, it can be implemented in parallel form or you can implement in cascade form. I just write it, you tell me what it is. This is x of n. I shift it one times. This is x of n minus 1. I shift it one more time. So here in this case what happens is I cannot cascade it, or cascading does not result in any fruitful things. So I sum it. So once I sum it, I scale it by 1 by 3. It will result in y of n. This is sufficient because s of n and s raised to minus 1 are independent of each other. If it was s raised to 2, I could have taken its help in order to reduce the hardware, but it is not happening. So this is a minimum hardware that is required and minimum time that is required. Hence I stop at here. So this is the answer for the given question. Let me go to the next one, that is LTI system properties or interconnections of LTI systems. Okay, so here we have three very important properties to be studied regarding LTI system. We know the response of the LTI system to some inputs. We actually know the response to many inputs. For example, commutative property, associative property, and distributive property. These three properties are holding good for LTI systems. That is what we want to test and analyze here. So we are starting with the commutative property. So what does commutative property tells? It is or for the convolution. So for convolution it is y of t is equal to x of t convolved with h of t is equivalent to h of t convolved with x of t. Both mean same. Just check here. X of t is at the input, h of t is a system response, y of t is output. H of t I take it as an input, x of t I make it as a system operator response, and y of t is the same output what I get. This is commutative property. For this, I need to derive some equations in order to prove it. So let me prove it. X of t convolved with h of t is nothing but what? Integration from minus infinity to plus infinity, x of 2 h of t minus 2 d2. Okay. So if I write it in this manner, what do you get? Minus infinity till plus infinity h of 2 x of t minus 2 d2. Now what I do is I apply a change of variable. So change of variable, how do I do? So I substitute t minus 2 with something like v, okay, or gamma, whatever you say. And here 2 becomes what? 2 I take it on the right hand side, t minus v. So I substitute it here now. So this becomes integration from minus infinity to plus infinity h of, in place of 2 I write it as t minus v, in place of t minus 2 I write it as v. So I have changed the variable, hence I have changed the variable from 2 till to v, so hence I write it as dv. Okay, so this is nothing but, this can be written as x of v h of t minus v dv. It can be written as, you just see here, replace 2 with v. It is same as this. In place of t you have t, in place of 2 I am having v. So for this, if I want to write it in the form of symbolical form, so I write it as x of t, see in 2 I don't write it here, t, this t, x of t convolved with h of t. Same thing, it is resulting in same thing. I started from here, it is resulting in the same thing. Therefore this is equivalent to x of t convolved with h of t is equivalent to h of t convolved with x of t. It holds commutative property. I hope it is clear to you. Next comes distributive property. Taking two systems like this, h1, this is h1, if it is not clear, this is h2, h1 of t and h2 of t, and it is, x of t is applied to these two systems. So I receive the output of the system at both ends. When I add it, I'll get it as y of t. That's the final output. Here it is written. This is x of t convolved with h1 of t. This is x of t convolved with h2 of t. When I add it, I'll get it of y of t. This is equivalent to a system whose h of t is h1 of t plus h2 of t. h1 plus h2. And then I apply to input, it will result in the same answer. That is what we need to check. Distributive property. So we are checking the distributive property now. So distributive property goes like this. Y of t is equal to y1 of t plus y2 of t. So y1 of t means what? X of t convolved with h1 of t. y2 of t means x of t convolved with h2 of t. Convolved. I'll show it here. Here it is. This is y1, this is y2. I have it here. Now y of t is given by This is convolution formula. Integration from minus infinity to plus infinity. X of 2 h of t minus 2. We know the formula of the convolution. D2 plus integration again minus infinity to plus infinity. X of 2 h of, so I forgot to write h1 here. h1 h2 h2 of t minus 2. This is D2. Okay, simple, very simple. Now what I do is I know that integration x of 2 is a constant. We have weighted sum or weighted integral. We already know it, right? So as it is a constant, I can take it as a common. This is a constant, I am taking it as a common. This is a constant. So if I take it common, what would be left? h1 t minus 2 plus h2 t minus 2 d2. This is what is left. Okay, so the addition of these two things, I write it as, addition of these two things can be written as h t minus 2 d2. Okay, so that's why say that x of t convolved with h1 of t plus x of t convolved with h2 of t is nothing but x of t convolved with h1 plus h2 of t. That is what is written here. So addition, it will result in the same answer. So it will result in the same answer, y of t. This is, I have started from y1 plus y2, y1 plus y2, it will result in this manner. Hence it holds distributive property. Distributive property. It holds good distributive property. Similarly, you can write it for continuous time, discrete time, sorry. In previous case, for commutative also you can write it in the same form for discrete time. Here also, I'll show it here. X of n convolved with h1 of n plus x of n convolved with h2 of n will result in x of n convolved with, in the bracket, h1 of n plus h2 of n. That's a distributive property for you. I hope it is fine till here. Next, associative property. So what associative property tells us, when I put this is cascade form, okay, and you can see here this is parallel form. This is parallel form, this is cascade form. So when the system are placed cascaded, then when I apply input here x of t to the h1 of t and then h2 of t, it is as good as applying input to the single system called h of t, which is given by convolution of these two systems, h1 of t convolved with h2 of t. It will result in the same answer. This is what we call it as associative property. Let us check. Okay, so here I name the intermediate as z of t. Okay, z of t is x of t convolved with h1 of t and y of t is z of t convolved with h2 of t. Okay, so let us verify. This is associative property. X of t convolved with h1 of t convolved to h2 of t is same as x of t convolved with whole of h1 of t convolution with h2 of t. So this is the associative property. We shall prove it. So first I start from y of t. Left hand side diagram, this one. What is y of t? Y of t is z of t convolved with h2 of t. Y of t is z of t convolved with h2 of t. I start from here and I prove that it is equivalent to the second diagram. The second diagram, that is this diagram. Okay, y of t is equal to x of t, h of t. So first I apply the formula. Integration from minus infinity to plus infinity, z to h2 of t minus 2 d2. Therefore, y of t is equal to z of 2 means, what is z of 2? Z of 2 or z of t is convolution of x of t h1 of t. Hence, in place of z of 2, I apply, we know that z of 2 is nothing but x of 2 convolved with h1 of 2. We know this. Or else this can also be written as integration from minus infinity to plus infinity x of, I don't use 2, 2 is already used, I use v, convolved with h1 t. In place of t I am having 2 here, hence 2 minus v dv. This is the formula. So I substitute it in place of z of 2. In place of z of 2 I substitute this formula. So one more integration from minus infinity to plus infinity x of v, here it is into, okay, not in convolution, h1 2 minus v, 2 minus v. Now what is left? h2 t minus 2. I am left with dv and d2. Okay, so this is the formula. Carefully you need to write. Now we perform change in variable for the integrals. I perform change in variable for the integrals. What I do is, in place of 2 minus v, what I do is 2 minus v should be substituted with, I take it as eta. Okay, so if I substitute 2 minus v with eta, then v can be written as 2 minus eta. Okay, this is for your information. Now you substitute y of t is equal to integration minus infinity to plus infinity x of, right now let me write v itself. Here I apply one more integration, because this is a constant, I'm taking it outside. I'm taking it outside. Minus infinity to plus infinity h1 t minus v, 2 minus v, I write it as eta h2 t minus 2. T minus 2 can be written as, just carefully listen, in place of 2, let me write it in the other way. In place of 2, what can I write? V comes on the right hand side, eta plus v it becomes. So in place of 2, I write it as eta plus v. So I get it as d eta, because changed variable, and last is dv, it is taken outside. So for this in inner integration, so you just here inner integration, this you concentrate. h1 of eta, h2 of t minus, there is something here, so this can be written as t minus v minus eta. This is h2. I am writing only this one, t minus v minus eta. Okay, so this is t minus v. What is t minus v? So t minus v minus eta it is. So hence, if I just write it as eta, so you know that at t minus t, this convolution can be written as minus infinity till plus infinity x of v, this whole can be written as h1 of t convolved with h2 of t dv. Okay, so hence you can write it as integration minus infinity to plus infinity x of v, this can be written as h of t minus v, okay, or t minus v dv, or this is equivalent to x of t convolved with h of t. So lot many things we looked into here, so this will give him the original answer. Okay, so hence it will satisfy what is this property called? Associative property. This is a associative property, quite complex, but if you just go through it once, it will be much more simple. So this is all about the three properties that we discussed: distributive, commutative, and associative property. Same thing you can apply for discrete time also. Okay, so in the next class we will look into the interconnections of LTI systems problems. Thank you all.